Okay, now this tutorial is one of the first on vibration. And what I'm going to do is to introduce a few formulae to do with vibration. One is to do with the natural frequency of the mass spring system, something that we'll be covering in the lectures. Okay, and it's this formula here. So this is the natural frequency of the vibrating system. K represents the stiffness within the system, so it's often called the spring constant, and M is the mass of the object that's vibrating. So this is a typical formula for the natural frequency of a mass spring system. What we're going to do in this particular tutorial is to rearrange it for K. It's a question that's often posed in the exam, okay? So you need to be familiar with the way in which you dissect this formula. So, taking the formula as it stands, all right, the K is already locked into this term here, which is effectively the square root term. So leave the square root where it is, okay, 1 over 2 pi. Well, we can forget about the 1, but we can't forget about the 2 pi. It's divisible here. Take it across to the side, it becomes multiplied. So that's 2 pi times f naught. When we get to this situation here, we need to get rid of the square root. So to do that, we need to square both sides. Okay, squaring a square root will simply remove it. So this becomes k over m. Squaring this side though, you have to square the whole term. So this becomes 2 2s are 4, pi squared, f naught squared. So all I've done is basically squared each of those individual terms. Keeping the k fixed on that position here, this becomes 4 pi squared f naught squared times n. One thing to remember, just a word of caution, when you work out your k value, okay, it's always going to be large, okay, for a mass spring system, because the mass is often quite large, particularly if you're looking at mass of machines, okay. So this parameter here could be quite large. Bear in mind also that we sometimes express the unit of K is newtons per metre. Because it's a very large unit, we sometimes express it in terms of kilonewtons per metre, or even meganewtons per metre as well. So just a word of caution that we can see it expressed as those two functions. In terms of K, it's 10 to the power 3. In terms of m, it's 10 to the power 6. So that concludes that short tutorial on the natural frequency.